Hello, today we're going to be doing section 8.1, which is about a geometric mean. But before we start that, I want to remind you what an arithmetic mean is. Back in the day, you learned about mean, median, and mode, and mean was kind of like finding the average. You took all of the numbers, maybe all of the test scores, and then divided by the number of people, and you got the mean, or the average score. So like if I wanted to find the arithmetic mean between 8 and 32, I would add them together, divide by 2, and get 20. Just like you see here. And you can see like the difference between 8 and 20 is 12, and between 20 and 32 is also 12. Well, the geometric mean is a little different. The geometric mean, you're trying to figure out what is the number that would balance out this equation. And it has to be the same number in both of these spots. So you use a technique that you learned in Geometry A called cross multiplication. You multiply the x's, you get x squared. 8 times 32, you get 256. Take the square root and you get x equals 16. So 16 is the geometric mean between 8 and 32. So imagine if I plug in a 16 over here. So I'm going to plug in a 16 here and a 16 here. You can see that that would balance out the equation. 8 over 16 would reduce to a half, and 16 over 32 reduces to a half. 16 is the geometric mean. Notice it's not adding the same amount between each number. In fact, from 8 to 16 is plus 8, but it's multiplied by 2, versus 16 to 32 is not plus 8, it's plus 16, but it is still multiplied by 2. So the geometric mean works a little different than the arithmetic mean. Okay, so let's jump right into the notes then. 8.1. Every proportion has what's called means and extremes. So in this case, the A and the B are the extremes. These other two spots where the x's are, those would be the means. But something kind of special happens if they end up being the same number. In this case, they're both x. Then they're called not just a mean, but a geometric mean. So again, every proportion has means and extremes. But if that number is the same, then it's a geometric mean. If you want to find the geometric mean between 8 and 10, you just set it up like this. 8 over x equals x over 10, and you try to find that number that would balance out the equation. So you use cross multiplication. X times x is x squared. 8 times 10 is 80. Take the square root, and x equals, gosh, I think it's 8.94, according to my calculator. There's no label here, so then we can just stop there. Now you try the next one. Try to find the geometric mean between 9 and 4. I'll put my answer up in a minute. As you can see, the answer would be x equals 6. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original and to each other. Imagine dropping down an altitude right here. Let's call this point D, capital D. What happens when I draw in that altitude or that height is it splits that original triangle into two smaller triangles. If you can imagine, this would be a right angle. If I take that small triangle on the left and I redraw it, it would go something kind of like this, ADC. There's the small one. If I take the triangle on the right, which is the medium triangle, and I redraw it, it would be the exact same shape. It would be similar, it would just be a different size. And then if you imagine the original triangle, this big triangle, if I redraw that big triangle, you have to imagine I'm kind of flipping it over and straightening it out. I'm going to get another triangle. All three end up being similar to each other. Same size, just same shape, just different sizes. And so up here we can write, if we drop down CD, which is the altitude, then triangle ADC, which is the small one, will be similar to triangle CDB, which is the medium one, and it will also be similar to triangle ACB, which is the large one. Also, if you drop down the altitude to the hypotenuse of a right triangle, so let's do that again, just like that, there's the altitude, this we'll call D, then it separates the hypotenuse into two segments. So you can see we have this segment right here and this segment right here. Something kind of cool happens. When we drop that altitude down, that ends up being the geometric mean between the two parts of the hypotenuse. So it goes like this. If I take the distance from A to D and divide by C to D, it should be proportional to C to D divided by D to B. And you can see this number is the same. CD goes in these two spots just like the geometric mean would go in those two spots. Okay, let's jump in and try one. So in this case, X is the altitude of the triangle, of the original large triangle, okay? I'm just gonna erase that. And so X will be the geometric mean between 5 and 20. So you start out like this. You go 5 over X equals X over 20. Then you're going to cross multiply, so you get X squared equals 100. Take the square root, X equals 10. Cool, now we have X equals 10. Next we're going to try to find Y. So you can see we have a little triangle down here. This corner would be a 90-degree corner. We have two of the three sides, so now we can do Pythagorean theorem. We can do 5 squared plus 10 squared equals Y squared. We end up with 25 plus 100, which is 125. And then we have to take the square root of 125. And we'll just do a decimal answer. So our decimal answer is Y equals 11.18. Last but not least, let's find Z. So now we're going to use this medium-sized triangle up here in the green, and we can do the Pythagorean theorem again. We have another right triangle, so we can go 10 squared plus 20 squared equals Z squared. So we have 100 plus 400 equals Z squared, which gives us 500. Take the square root, and Z ends up at 22.36. So just to recap, we did the geometric mean once to find that altitude, and then we did Pythagorean theorem, Pythagorean theorem. Okay, let's try this one. Here you can see the altitude is 12. This is the number we have to use twice. 12 will be the geometric mean between the two parts of the hypotenuse. So we set it up like this. X over 12 equals 12 over 9. So it's not always the X that gets used twice. It's the altitude that gets used twice. When you cross multiply, you get 9x equals 144. Divide by 9. X is 16. Now we know this is 16. And then again, we jump in and we do Pythagorean theorem twice. So we can use this left triangle over here, and we can go 16 squared plus 12 squared equals Y squared, and we can solve for Y. I'll let you do that. And then we can also do the right triangle, which is over here. So we're going to do 9 squared plus 12 squared equals Z squared and solve for Z. Why don't you take a second and find those two answers. Y should be 20 and Z should be 15. One last problem here. This time the altitude is W plus 4. So W plus 4 is the number that we're going to use twice in the geometric mean. So 24 over W plus 4 equals W plus 4 over 6. Cross multiply. This one's going to be interesting. We're going to take W plus 4 times W plus 4. 24 times 6 is 144. Now this w plus 4 times w plus 4, we have to FOIL or box method. When we FOIL, we take the firsts. W times w is w squared. We take the outsides, which are w and 4. Multiply, we get 4w. Take the insides. Again, we get 4w. And then take the lasts. The last thing in each parenthesis is 4 and 4. Multiply, you get 16. Most people know that we should combine these. So we get w squared plus 8w plus 16 equals 144. But then a lot of people get stuck here on what to do next. They try to move the 16 and things like that. What you actually want to do is get a 0 on one side. So subtract your 144. And you're going to wind up with w squared plus 8w minus 128 equals 0. So at this point now, you're going to do something called factoring. So you're going to try to think of what two numbers multiply to be negative 128, but add to be 8. It turns out that I think it's 16 and negative 8. So if you're thinking about those empty parentheses, I don't know if you remember doing this in algebra, but the front of each parenthesis gets a w because they have to multiply to be w squared. And then the 16 goes in one of them and the negative 8 goes in the other. Now to get your final answer, you set each of those equal to 0. So you go w plus 16 equals 0 and w minus 8 equals 0, and you solve each of them. So in this case, we would minus 16 and we would get w equals negative 16. And in this case, we would add 8 and we would get w equals 8. Now, you have to check, do both of these make sense? The negative 16, if we plug it in for the height or the altitude, doesn't really make sense. We'd wind up with a negative 12 for a height, and you don't want a negative height. So you just cross that one out, and our answer is 8. A lot of people, when they get to this point, they just take the opposites of what the factors were and skip all this work down here. So you can do that as well. Take the opposite of 16 and you would get negative 16, the opposite of negative 8, and you'd get positive 8. All right, good luck. Try the 8-1 homework, and we'll see you later. All right, have a good night.